Alright, so now for the last problem that we're going to discuss with L'Hopital's rule. So this is our problem, and we always want to start with direct substitution. And when we do that, we get infinity to the 1 divided by infinity. 1 divided by infinity is 0. So we get infinity to the 0, which unfortunately is an indeterminate form. So now we want to use L'Hopital's rule on this, but similar to previous problems, this isn't exactly a fraction, so we got to do some gymnastics to get it in the form we want. And as you'll start to notice, when you have something in the exponent, especially an x term in the exponent, you're going to be using logarithms to get that exponent down in front to actually be able to do the problem. So you take the ln of both sides, and the unique properties of limits allows that that logarithm to move inside of the limit and then modify that 1 over x. So we can say ln y equals limit as x approaches infinity of, and then this 1 divided by x moves down in front because properties of logarithms say if the whole thing is to a power, then that power can come down in front. So you're going to get 1 over x times ln of 4x. And this one is actually kind of nice because remember, our end goal with these L'Hopital rule problems is to get a fraction, right? Because we can use L'Hopital's rule on a fraction. We need a numerator and a denominator to take the derivatives of. So, and this kind of already almost is a fraction, right? We can just say ln of 4x and then just divide by that x, right? So now this is pretty sweet. We will use L'Hopital's rule on this, and the derivative of our top, so we're going to do a derivative of ln of 4x, which is going to be 1 over 4x times 4, and that's a little chain rule problem, divided by derivative of x, which is just 1. And we're still looking at as the limit as x approaches infinity. We can simplify this a little bit. We can just get rid of this 1. This 4 in the numerator cancels with this 4 in the denominator, and so we're just going to get 1 over x, limit as x approaches infinity of 1 over x. And if we recall our graph of 1 divided by x, it's going to look something like this. And as we get closer towards infinity, we approach 0. So we're going to get limit as x approaches infinity of 1 over x is going to be 0, but don't forget that we've been using ln y, so we need to add that base of e. And then so we're going to get y equals e to the 0, which equals 1. So our answer will be 1.